All right, welcome to the first part of 4.3 Quantities in Reactions. This is video version 2, 2018 version. Okay, Quantities in Reactions. This particular video will cover the first box pretty much only. Chemical equations can be written to describe a chemical change. What you need to be able to do is to write chemical equations when given the reactants and the products of a reactions. So yeah, pretty much back to basics of what chemistry is about, the study of change. Okay. All right. So let's think about some context where chemical equation and what you can tell, which is called stoichiometry, is important. All right, imagine that you're a chemical engineer, or if you know a chemical engineer, think about what sort of jobs they might do. Something that pops up in my head is that, say, chemical engineer who works at water purification site, so water recycling site even. So think about the water that you flush down to toilet, where does it go? If it's around this area, it goes to wastewater management site in Bolivar. One of the last steps is to add a chemical called alum or aluminium sulfate solution into fairly clean water. By doing so, it will clump up to a sludge which sinks down and you can filter out. So you can be left with a bit clearer water. Now, if you add too much of it, I'm pretty sure your boss wouldn't be happy because it means more money, more costs would be involved. If you know how much you're adding to, say, 1 gigaliter of water that comes in every minute, yeah, your boss would be happy. You are hired for a reason. There you go. So that's what chemical engineers would always have to think about, how much is necessary to be added to the reaction vessel so that their reactions would be viable. Now, for you to know that, for them to know that, they actually have to look at the ratio of reactants and products, or reactant to reactant. And you use number of moles to calculate that. Now, first step for you to do that, first step for you to think about the stoichiometry, which, well, what's written there is how the relationship between reactants and or slash or products in a chemical reaction can be used to determine desired quantitative data. Okay, so if you know exactly how much you're adding, you can predict how much you will get, theoretically anyway. Relationship that we are talking about would be mole ratio. So for how many moles of reactant, how many moles of product you would get, or how many moles of reactants you would require, look at the ratio, to achieve certain amount of product. That's what stoichiometry is about. Okay? So what's the first step for you to do? Well, you need to be able to write chemical equations. Okay? You need to be able to write a balanced chemical equation. Okay? That is essential for you to work out the mole ratio. All right? From that mole ratio, what you can get is, because you already know the ratio, it's relative. Changes are relative. So if you decrease one of the reactants, both reactants to twice or 3 times, you get twice or 3 times of products. That's pretty much that in terms of, in number of moles. So that yield of product in moles and / or grams can be determined mathematically. So quantitatively, you can guess that. Very important skill. All right, now here's one example. So what sort of information can you get if you manage to write a chemical equation? So for example, this one of the favorite reaction that everyone would want to do. Sodium, solid, into water. You know what happens? It's called because of the hydrogen that is generated. And sodium is called one of the alkali metal for a reason. It makes NaOH in the water. So NaOH is one of the strong basics substance. So yeah, that makes the whole water more basic. All right. So what information can you tell? Well, firstly, for every 2 mole of Na, 2 mole of H2O is required for it to fully react, because it has 2 and 2 in front of Na and H2O respectively. Yeah. What else can you get? For every 2 mole of Na, which fully react with water, 2 mole of NaOH is produced. For every 2 Na, you get 2 NaOH. So 2 to 2, it's really 1 to 1 ratio. Okay? But it's in moles. Thirdly, what I could come up with was when every mole of sodium metal reacts with water, 0.5 mole of hydrogen gas is generated. Why 0.5? Where did I get that from? Because I can see 2 to 1 ratio in front of Na and H2. Okay? If there was twice as much of Na necessary for you to generate 1 mole, okay, the ratio still stays the same. 2 to 1 equals to 1 to 0.5. There you go. So mole ratio is very useful. Now, activity that we'll do in class, we'll look at some of the practice questions in Kang Academy website. There's a link. You can have a look at it as well. Move to stoichiometry video, and you can do two more practices. We might include some questions from there into online Canvas quiz, maybe, and also a few questions that we can do. All right. Now, how are these information going to be used later on? Well, you will be able to use these things here. Okay. What you see in this slide is molar concentration, mass concentration, percent per weight per volume, parts per million, parts per billion. So they are the units that you have to be able to work with and the calculations that you need to be able to do. And you do that using the ratio, which is called stoichiometry. All right. So that's going to be what this 4.3 quantities in reaction of subchapter is going to be about. All right. Watch the other videos which talks about each one of these concentration of a solution units specifically. All right. So make sure you go watch that. Make sure you get used to how to use mathematics in chemistry context. All right. That's it for this video. All right. I'll see you next time.